Hello, my name is Ellen McElhatton, and I will be applying the Lover-Hater Battle of the Sexes game to a Christmas-themed example. Santa's elves building toys in the workshop. Here they have the choice between producing toy trains or dolls. In this example, we have two elves, Sparkles and Buddy. Buddy has complete information and two personality types, L and H. Type L loves working with Sparkles, whereas Type H hates it. Sparkles has only one type and is uncertain about Buddy's type. She believes the two are equally likely. They are not able to communicate before arriving at work, and they are unable to switch once they have begun making the toys. As there are two personality types for Buddy, there are two payoff matrices for this game. The matrix on the left shows the different payoffs if Buddy is an elf that likes Sparkles, which means that he would want to work together and would get more utility from doing so. The matrix on the right shows the different payoffs if Buddy hates Sparkles, which means that he would not want to work with Sparkles and so would get more utility from working alone. Remember, Sparkles does not know which type Buddy is and considers L and H to both be equally likely. Sparkles prefers to make trains and Buddy prefers to make dolls. However, elves that get along always prefer to work together. In this way, it is a Bayesian adaptation of a Battle of the Sexes game. In order to solve it, we must first put it into strategic form. The strategic form game will be a 2x4 matrix and is calculated using the expected utility payoffs from each potential outcome. EU1 is the expected utility payoff for Sparkles if both elves choose to build trains. The payoffs are multiplied by 0.5 as each type is considered to be equally likely. We do this for every potential outcome of the game. Now that it is in strategic form, we can look at solving it. We first look to see if this game has any pure Nash equilibria. For Buddy, we can see that he will never play TT, as it is weakly dominated by the action DD. Therefore, we can eliminate it from the scenario. There are no other dominant strategies, so we will consider each player's best response to the other's potential actions. If Buddy takes Sparkles choosing to build trains as given, Buddy's best response will be TD. And if Buddy takes Sparkles choosing to build dolls as given, Buddy's best response will be DT. And now, doing the same for Sparkle's best response to Buddy's actions, we can see her potential actions. As each player is able to see what the other player's best responses are, Sparkles will see that regardless of what she chooses, Buddy won't choose DD, as 5 is greater than 2.5 and 7.5 is greater than 5, meaning that we can eliminate DD. Now that TT and DD have been eliminated, Sparkles has a strictly dominant action of choosing to build toy trains over dolls. Therefore, TDT is the only pure strategy Nash equilibrium of the game. What have we learnt? We have learnt that only one Nash equilibrium exists at TDT. Essentially, this means that if Buddy likes Sparkles, then he will forego his own preference of building dolls over trains in order to work with her, and they will both produce trains. However, if Buddy does not like Sparkles, then he will choose to make dolls over trains, as he would prefer to avoid her, meaning that Buddy would produce dolls and Sparkles would produce trains. This game also has two mixed strategy Nash equilibria that I do not have time to discuss here, but show how Sparkles and Buddy will mix between their potential actions in order to maximise their utility. Thank you for listening.